Hello everyone, welcome back to the channel. Today we are diving into a super important concept in operating system. It's mutexes or what is a mutex? A mutex is a short mutual exclusion, is like a lock that help manage how different part of a program takes turn using the same resources. Imagine several people trying to use the same bathroom key, only the person can have the key at the time. So other have to wait. Basically, what a mutex does in computer program, it stop multiple, threads or processes from messing with the same data at the same time. What is mutexes? When many threads think of them as a smaller part of a program running at the same time. Try to change the same piece of data. Things can get messy. For example, if two threads try to increase the value of a shared counter at the same time. You might end up with the wrong final number because their action overlap unpredictably. This program is called a race condition. Mutexes prevent this chaos by allowing only one thread to enter the critical section, the part of code dealing with with shared data at a time. A mutex compare with semaphones and spin locks. There are a few ways to manage access shared resources. First one is the semaphones. Think of these like counter. They let certain number of threads use a resource uh, stimulationally. If the count is one, it behaves like a mutex. Semaphones are often used as sign between threads. Spin locks. These keep thread spinning and in loop checking if it can get access. It's good if the wait is super short, but waste CPU cycles while waiting. Mutexes, on the other hand, make the thread sleep while it waits for the lock, which is more CPU friendly but can be slower if locks are held for long. Imagine you live in a house with one bathroom key, shared among all family members. The key holder gets exclusive access to the bathroom, while everyone else waits outside. This prevents two people from trying to use the bathroom at once and chaosing and preventing chaos. The bathroom key is the mutex that ensure mutual exclusion. I will provide you now a code. So this code is without mutex. Here in the code, there's a 5 threads trying to add a shared counter without a mutex. Their operation overlap and the final count 1. Why be what you expect? Importing thread counter equals 0, different increment, increment. So what happened? The expected result is 500,000, but you likely see a smaller random number because threads step on each other toes. I will provide now with a code with a mutex. By adding a lock, we make sure only one thread change counter at once. Now the output will reliably be 500,000. What could go wrong? Issues and advanced topic. Mutexes are powerful but need to be used carefully. Deadlocks. Imagine two threads waiting forever because each has locked a resource at other need. That's a deadlock. Sometimes a high priority thread wait because a low priority thread hold the lock. Fairnesses. Some thread might never get the lock if other keep grabbing it first. How to handle this issue? Use timeouts with lock to avoid waiting forever. Apply priority in inheritance, temporary boosting the priority of thread holding important lock. Design your program to acquire lock in a consistent order to avoid deadlock. Use fair lock that guarantee no one starve.